We're asked what are the regions that satisfy the shaded part. Yeah, as you can see, look at the shaded part. We're asked to find the region that satisfies that. Common sense will tell us that this is an inequality question. Yes. So what we're going to do is first look at the shaded region, is this part. And as you can see, it's bounded by this curve 1 and 2. So we have two quadratic curves bounding the region. So we need to get their equation first. That's the equation of this first curve and the equation of the second curve. Every quadratic function is of the form. We have two forms depending on the equation. As you can see, I'm seeing the x-intercepts and also the y-intercept. So we'll use this form, y equal to a x minus alpha times x minus beta. That's the general form. Where, okay, let's write the second form. Y equal to a x minus h all squared plus k. So these are the two forms of quadratic functions. So where alpha and beta are the x-intercepts. The second one, h, as h and k, is the coordinate of the vertex. So but in this case, I'll prefer using, okay, I can use the second case for the dotted curve because I'm seeing the vertex. The coordinate is 1, minus 4. So I'm going to use the 2. Though you can use 1 for the 2. You can use any of these to get the quadratic curves. But in this video, I'm going to use 2. For the first curve, that's the dotted curve. As you can see my vertex. The vertex is the maximum or the minimum point because I have my grid line here. So let me locate the coordinate of my vertex. So the coordinate here, as you can see, is 1, minus 4. So our h is 1 and our k is minus 4. So I'm using this second form. So I'm saying that we have y equals a x minus 1 squared minus 4. That's plus minus 4, which is minus 4. So I'm telling you, I'm getting my first curve, that's the dotted curve. I'm using the second form of equation of I'm using the second form of quadratic function, which is this. So that's the first thing. But we still have an unknown here. We need to get the value of this unknown. And how do you get it? We look at any other point on the curve aside the vertex. And the best point I will use here is the y-intercept. Yes. We can still use other points. I can still use this. I can use the x-intercept. So my best point is either I use the x or I use the y-intercept, because these are the two known points that are on the grid line, major grid line. So let's use the y-intercept. So at 0, minus 3, you see that y is minus 3, yx is 0. So we'll solve for a. Solving for a, this is 1. So 4 minus 3 is 1. So a is 1. So our a for the dotted curve is 1. which is correct because this is concave up. Concave up, the coefficient of x squared is always positive. A is positive. So we have our curve as y equals 1. So no need of writing 1. X minus 1 squared minus 4. So we can expand further, which is x squared minus 2x plus 1 minus 4. So we have y equals x squared minus 2x minus 3. So that's the equation of this dotted curve. So that's the first step. So the second step is to get the equation of this solid curve. So I will use this first one because I'm not seeing, I can't easily picture my vertex. It's not on the grid line, major grid line. So it's better I use this. As you can see, I'm seeing my x-intercept, which is minus 3 and 2. So let's move to the other page. Okay, we are now using this first function, which is y equal to a x minus alpha and x minus beta. And from the curve, you can see that my x-intercept is minus 3, which is x plus 3 now, times 2, which is x minus 2. Okay, but we still have an unknown here. We need to get the value. So what do? You choose extra points on the curve. Just choose one point on the curve, and the best point is my y-intercept. Yes, so that's a known, it's the only point. Okay, I can still choose this point. It's on the major grid line. So that's the essence of giving us this graph with grid line, so we can locate some necessary points. So let's use at the y-intercept, which is 0, 6. So y is 6, x is 0. So we can still look for a. In this case, this is minus 6. So we have minus 1. So a is minus 1. As you can see, is a concave down curve. And what do you know about that? The coefficient of x squared must be negative. So as you can see, a is negative. So let's now get the function, which is y is equal to a is minus 1, x plus 3, x minus 2. So which is minus 1. So if you expand this x squared plus 3x minus 2x is plus x minus 6. So which is minus x squared minus x plus 6, which is correct. As you can see, the y-intercept is 6. So we've gotten the two curves. So to locate the shaded region, that's where inequality, because what we've found now is just the curve as points on the curve. Well, the shaded parts are points that are not on the curve, though some are on the curve because of the shade. Like for this thick line is included, but for the dotted line is not included. So what do? We now pick points on this shaded part. Just pick a point on that. So we have two curves now. The first one is y equal to x squared minus 2x minus 3, x squared minus 2x minus 3. Why the second curve is minus, I think minus x squared minus x plus 6 minus x squared minus x plus 6. So as you can see, this is the first one is the dotted curve. So this is the dotted curve, while this is the solid curve. So what do? We just pick a point on the shaded part and test on these two to know the sign that will be correct for our inequality. So let's pick a point. Okay, so the best point I will use, let me use this point. So we use at minus 2 comma 0. So let's test the two curve. We have that minus 2, sorry, this is 0, y is 0, x is minus 2 squared minus 2 times minus 2 minus 3. Yes, so we have 0, this is 4. So 4 plus 4 is 8. 8 minus 3 is 5. So what do you notice? 0 is not equal to 5. True or false? So it's false. So the best sign is that 0 is less than 5. And since we have only dotted line, we won't include it, because I told you if it's solid line from our basic inequality, solid line means that it's also part of it. We put equality sign. So that's the best. Therefore, the curve that will satisfy that is now, which implies that is now y is less than x squared minus 2x minus 3. So let's test the second curve. So at that same point, because it's part of the shaded region, so we have 0 is equal to minus 2 all squared minus 2 plus 6. So what do you have to say? This is minus 4 plus 4. So this minus 4 plus 4 is 0. So 0 plus, so we have 6, which is also false. So the best sign is that 0 is less than 6. Yes. Therefore, the curve is now y less than, but as you can see, this is a thick line. So we include it less than or equal to minus x squared minus x plus 6. So these are the two inequality that satisfy the given region. So this and that. So that's our answer. Y is less than x squared minus 2x minus 3, or y is less than minus x squared minus, so that's the region bounding this. So thank you.